The proposed activity aimed for Year 1 students uses BBots as a digital technology. The Australian curriculum requires them to understand the functions and components of a BBot to be able to create a sequence of steps from one location to another. The activity will enhance students' knowledge as it acts as a preliminary activity for the lesson. Students are given the opportunity to familiarise themselves with the functions of the BBot and the computational thinking needed to ensure they understand how to use them when they are introduced later on. Guided questions such as, if I press the forward button once, what will happen? Encourages students' computational understanding. The lesson makes connections to various different learning areas. STEM is incorporated through the inquiry process. This lesson focuses on the investigation stage. Science and engineering are incorporated as students explore the forces and programs that make the digital technology move. The lesson also links to the mathematics curriculum as students explore location and direction with the BBots.
Lesson 2 requires students to follow and give directions. In groups, students will take it in turns to direct their peers around the tape grid on the floor. This activity is accompanied by a poster of the BBot buttons. For example, Student 1 might ask Student 2 to move right 1 place and forward 2 places. Student 3 will then use the poster to accompany these directions as shown. This activity allows students to become familiar with the functions and algorithms of the BBots. The use of the poster alongside the activity will continue to develop the knowledge of coding and computational thinking necessary for Lesson 3. Lesson 2 fulfills the Australian curriculum requirements for digital technologies as students recognise and explore the components or systems of BBots, use the poster to recognise and explore BBot patterns, follow, describe and represent a sequence of steps and decisions needed to move their peers from one location to another. The lesson makes various connections across the curriculum. The lesson links to the English curriculum as students will give commands or directions and may need to ask questions for the information needed. Students are also required to take turns, speak clearly and use appropriate volume and pace. The lesson makes connections to the mathematics curriculum as students will give and follow directions.
Moving on from Lesson 2. Lesson 3 comprises of students creating their own directional instructions using a large-scale map in a BBot. This lesson enhances students' development on foundational skills in computational thinking, as well as awareness on personal experience towards coding. Students begin to learn and present their understanding about directional patterns that exist within sequences of instructions. Students will be able to identify the significant steps involved in designing and making a directional instruction by conceptualizing algorithm as a sequence of steps. Based from the Australian curriculum, throughout the lesson, students will have opportunities to create a directional instruction using technology through guided play, as well as integrating their learning through exploring and navigating large-scale map and using a BBot. This hands-on multisensory activity expands their mathematics fluency towards counting numbers in sequence and developing their problem-solving skills by having them create an instructional direction using rarely used resources. Throughout these 3 lessons, students learn and apply appropriate language features to carry out the activity, for example, using directional terminology. When carrying out these activities, students are developing their receptive mode by listening to others when taking part in conversation, as well as a protective mode when interacting in pairs, group, and class discussion.